Hi, my name is Stephen Proud, and today I'm going to show you a video that allows you to configure a ControlLogix PLC or a CompactLogix, all the same software, um, using the latest Festo function blocks, FHPP version 2.2 library available on the Festo website. And I'm going to connect to their Festo controller, a CMMP-AS. I hope you enjoyed this video. Thanks.
With the Festo exercise today, we're going to need the FHPP function blocks from Festo. First thing we need to do is download these. Go to festo.com. Select your country, go in. The support download area is where you get all your software, technical manuals. With today's exercise, we're looking for the function blocks, so type in Rockwell. This is one method. You'll see that the function blocks, there's two different versions at the moment. Today is April 2016, and we've got a version 101 and we've got a version 2.2. An alternative way of getting to this is to put your controller when you do the controller, you get the latest version. I don't see the, oh, okay, here's the other one. So either way, you select the function blocks you want. Today we're dealing with version 2.2. Again, it's called the FHPP library for Rockwell PLC, and it's version 2.2. Click on the function blocks. You will download and install that to a directory. It'll be an exe executable file, and you put that somewhere that has admin rights. So when we have that, then the next step when you've unzipped the directories, you have a couple things here. This text here is not part of the library, but you'll have this here. You'll have the function blocks, version 20, and without version 20. So from version 21 and up, you will select the version without the V20 appended at the end of the text. Also within the library is the documentation. This is an important piece of the puzzle here. This will take you through and explain the library, which is what we're also going to do a little bit today. I'm just going to close this. There's some example code within the library as well. I don't know what version this is. It's possibly version 21. And now we're going to import these to our project. Okay, so for importing function blocks or AOIs, so I am in my library that I've unzipped to a directory. Go into my add-ons, and this is a version 19 ControlLogix project, so I'm going to try to import all the version 20, and hopefully it works. It should add any user-defined data types that are required as shown here, and I will continue to import. If you're just doing basic control, this should be about all you need. You've got the control, which will act on the variety or the majority of the controllers that Festo offers. I think the motor DCI is excluded. The FML read and write map the real world data and configuration. This is the main control block, and the FHPP Plus is something that you would modify in the FCT project and configure what you have mapped to come across. I'm going to keep mapping the parameters. So there's quite a few different FPC blocks. I'm just going to import them anyway. Now, all of these blocks that are in the library don't necessarily act or don't necessarily work with all of the motor controllers that Festo offers. This is mentioned in the user guide. Okay, so now we have all of the function blocks mapped or imported, and the user-defined data types that go along with the project are all in the project as well. Save the project. Okay, the next step is to leave the Rockwell for a minute and go to the FCT configuration that Festo has. I'm online here. I've already created a project. I can go offline and show you real quick. I've got a CMMP controller with a Ethernet card, slot 2. I've got a safety module in slot 3. Any motor and any axis will work, of course. This is configured in here, but I'm not going to cover this today. Hopefully you know how to do this. I always use the next and previous buttons just to make sure we don't skip over anything. This is the important piece of the puzzle. When dealing with Rockwell and the CMC FPP card, Ethernet card, it's important to understand what firmware version you have and what hardware version you have of the CMC FPP. There's a version 3 and there's a version 2 or older. So today we're going to be using a generic module, and the firmware is at the moment 4.0.15.01.2.2. We have Ethernet IP as the interface. More or less everything else is default. Limit switch I'm using for homing. Your axis length, size, everything will be applicable based on your actual hardware. I keep jumping through here down to the Fieldbus. You see here over here it's jumping through. We could manually go here. Basically over here we're using the Festo parameter channel and the control data. So 8 bytes for control, 8 bytes for Festo parameter. And this is kind of standard. It's important to understand when you're using FHPP that you want to turn on the factor group. This will scale your increments in your controller to your project units. And the exponent of -3, for example, we give you some decimal points because everything coming across is whole numbers. Direct mode, this here affects the FHPP profile being used. We can or cannot use the record table. It depends on how you're controlling with the FHPP. The next step is to add your generic module. Select new module, communications, generic module. We're going to select data type of SYNT. This is required because the newer FHPP version 2.2 library requires SYNT as the data type. Give it a name. And instance 101 will be 16 bytes. 100 will be 16 bytes. And 102 will be 0. The IP address of the controller is 192.168.1.45. Okay. The CMMP FPP is capable of 1 millisecond, according to Festo. Your project will determine whether that's practical or not. Definitely select unicast, hit OK. That in terms will create your data types. So the generic module is now added. Next step will be to add tags or add the AOIs from Festo. Okay, so we have added all of our AOIs. We have added our generic module. The generic module matches our FCT configuration. We have our IP address. The firmware factor group is used. That will scale everything properly. We have 8 bytes in for control data. Parameter channel, another 8 bytes. With the answer, we've got 8 bytes control. So 16 bytes in and out. And the next step is to add tags, the tags that will reference the AOIs. Now I've added some of my own user-defined data types. This particular one, I will nest the function block for the FHPP control. So under controller tags, we simply come into here, start adding tags. This one here, so there's our function block for FHPP control. And the data reference will be the next one. And we will continue and we will add all of the tags. Okay, I've added some of these at the liberty of myself on other projects, so I'm just copying and pasting tags. So as we see on the right hand side here, all of these data types are of the type either the data reference over here or are of the function block or AOIs themselves. So we've got my own tags, and we've got write status, read status, PNU. Control, data reference, diagnostic, status, direct mode status, FML read and write. We've got the multi, PNU, read status, write status, debug for me, fault for me, flasher for me, PLC status for me. So we now have all of our tags added. Next step is to add some code. I've added a routine here just for myself. I like to add my own code for monitoring the PLC. I've added some values to get the status of the module here. I've added, that was for the master card. This one here is monitoring the module itself. And now we're going to add the function blocks, or the AOIs themselves. Okay, so recap. We've added the generic module. We have added the AOIs. We have added the tags that reference the AOIs. We've added some generic code, and I would do it all in front of you, but I've added my own code now. So the function blocks are the AOIs. All right, so we'll discuss this now. So these bits here, this is just monitoring of the Ethernet master and the module itself, which is basically this master and the module. So only if we have communications and no faults are we going to execute any of these function blocks. That's a given as well, okay? So when we want to understand and configure these blocks, then we go to the library. Okay, so again, the library which was unzipped has the documentation directory. Open up this file right here, and this particular sample is showing a different controller, a EMCA, which I'm not showing here. I'm showing a CMMP. The important thing to understand here is that the function block here, which let's see if I can blow it up here, so that's a little bit larger for you to read here. It's about as big as I can go. So we have a device type, and if you read the manual, I've written up here the device type of 30 is a CMMP-AS controller. All right. This Modbus and high byte first, we're not communicating over Modbus, and we're not swapping any bytes. The FHPP in start address. Okay. So we've added a generic module. So this generic module here is shown right here. So we have our 16 bytes. So this tag right here is what we reference to this iData here. And we could have a variety of things in the same, there's quite a few configuration options, but this here, we're specifying our first byte. So in our circumstance here, byte 0 is our starting address. This can be different, but in this case it's not. So the next thing here, if you read the manual again, config FPC, that basically signifies that the Festo parameter channel, which is this parameter channel right here, the second 8 bytes, is in fact active. Okay, so we're turning this on. And the next thing it's asking us for is FPC in, so that's the starting address of the FPC area or data area. And we've got 16 bytes, 0 through 7 is the control area, 8 through 15 is the FPC area. So FPC, FHPP. All right, so we're starting at address 8. This right here, this config FHPP plus in, this is only if you're using FHPP plus, and in our circumstance, we're not. I'll just quickly show you. Basically, if you come in and you edit the FHPP area, you could, for example, set up acceleration so that it's there. Hit apply. When you do that, you get a PLC configuration number, and that's the number that you will enter right here. So I would put a 44 here, for example. In my case, I'm not. So I'm just going to revert back. And the same thing would apply for the other one. And again, you would have a starting address, which would be, you know, if you go back to the, it would be 16, you know, or if you turned off the FPC and we're not using it and you wanted to start FHPP plus here, you could start it here. So it's kind of hit and miss on what you want to do and how you want to configure things. So back in my configuration, I'm just going to get rid of this. So we're back to 0. So there's nothing being used here. Go online here. So that is how you configure the FML read. And I've explained this here just for the sake of having it. Now that's always the first AOI because you want to order these, okay? The next one is going to be our control block, and I'm going to scroll all the way to the bottom here to our FML write. So it's kind of the same line, except you don't need the other configuration. We're just simply setting up our starting addresses for our output data for FPC, FHPP, and FHPP plus. So again, FHPP, it's a mirror image of the input and output. So we've got starting address of 0. We're using this, which is this right here, our generic. So this again is FHPP, and this one right here is FPC. And if we had FHP plus, it can start here or it can start later. But in our case, we're starting at 0, starting at 8. That's not being used, and therefore this is not being used. And then this here is the status, this tag here. And with our function block for our main control here, we've got operation mode, and I've given you what these mean. Record mode is 0, direct position is 1, and some of these work with this controller, some of them don't. So you have to read the manual, which again is this manual right here. All right, so we've added all the code. Next thing we're going to do is we're going to download and try to manipulate some of the data. Recap again. So added our generic module. IP address 45, 16 inputs and outputs of bytes. Connection is unicast. We're not online, we look at the info. We've added all of our AOIs. We have added all of our tags, which reference our AOIs. We have added some PLC and some master and module status. We've added our AOIs and configured them. The FPC, I'm not going to talk about this particular moment, but the important ones right here, just to get control, are the FML read, the control. Let's zoom in a little bit here. So FML read, FML, or the CMMP control, and then all the way at the bottom, because we want this to be scan last, is the write data, so FML write. So those are the minimum requirements for control. Now we're going to go online. We're going to set the project path, download, put it back into run mode, and we're running. So master module, we have this is our module info here. Active 100 megabytes. We're not using a DLR network. Okay. Our generic module, we're up and running. Module info. This 160060 is fine. This is just an internal state. This is not a fault. It's just a status area. Module identity is a mismatch. Well, if I go offline here, there's nothing to do about setting it to mismatch. All right, forget about that. So go back online, download. Why do I have to download again? Well, I'll do it again anyway. I guess it thinks I changed something, but I really didn't. That's fine. Yes. So we have no faults. You know, if I walk over to the controller and I disconnect the cable, I lose the module fault. Plug it back in, and now I have no fault. So we are communicating, and we have data being written. If you go up to the controller tags and go to our I/O, under monitor, you'll see here that we have data on the inputs, right here and here and here, nothing on the outputs yet. And that's because everything basically is nothing. So any of our controllers, we need the halt bit. Of course, we have a fault. So see the fault right here, so we're going to reset the fault. All right, so the fault's been reset. Turn on the halt. Halt becomes active, turn on the stop, and enable the drive. So drive is enabled, ready, motion complete is on. At this point in time, we can execute the start homing, but I'm just going to show you what we can see here. We've got the FHPP monitor, so just like we have, this is from the PLC, so this is our outputs here going to our data area here. I don't know if I can move this down so you can possibly see what's going on. So the start homing, that'll be the cpos.home. So I'm going to home the axis. It turned on, the axis homed. We now have a homing valid. Now we're capable of doing moves. I can jog the axis, positive. And as you see, the actual position is being updated. Again, because we set up our factor group as 10 to the minus 3, you'll see here that our position right now is 70.87 millimeters. So in the controller, in the PLC, that should be 7087 and then another decimal point. So 70874. So you can only see it here as 2 decimal points, but in the over the Fieldbus, you'll get the third digit. So at this point, we can execute a record table. So if I execute record number 2, or record number 3, we should go to position 200. So down here, record mode is OPM 0. So OPM is 0 here. Put a record number of 2 in here. And turn on the start task. So I picked the wrong record, but still it moved to 350 because 350 is the target position for that. It echoed back the actual record number after it started its move. It doesn't do it prior to, only after it's started does it echo it. And the motion complete is done. The acknowledge is a mirror image of the start bit. So that was one move. So next thing, we'll just show a quick little sample. We're going to go into record mode. Record mode or direct mode is 1. 1. And in this case here, you will put a velocity and a value. So when we talk about that, we're talking about the direct mode. So the base mode, base velocity is 1,000 millimeters per second. If you look at the memory map, this right here is a percentage of that value. So 20% would be 200 millimeters a second. And there's our target, which is 10.000 millimeters. And we turn on the start task, and it moves to 10, and so on and so forth. And that's as simple as it gets for operating a Festo motor controller with the FHPP version 2.2 library from Festo. I'm going to go on to the other. Okay, so we also have this right here. So this is the Festo parameter channel. And we have diagnostics. Message number is a 2. Message number 2 is error cleared. So there's no errors right now. If you look at this here, same thing. Again, these are all explained in this particular manual here, which is with the library. And if you don't find the information here, then you'll find it in the Festo user manual, I presume. This is another important one right here. Okay, so many times, well, in direct mode, what you can do is change the velocity and then set a target and do a move. And a lot of people would like to change the accel, the decel, or the velocity max. So what this function block here has is it gives you access to these values right here. Okay, so if I do a read, so if I don't specify a 1 here and I do a 1, then I'm getting that value right now. And if I change it to a write, so that the read values came through here, the write values will go out here. So I'm just going to change this to 90,000. Change this to 2, 3. And just for the sake of it, I'm going to do a upload here. So uploading from the controller into here, we have 1,002 and 2. And I'm expecting a 900, a 3, and a 4. So do a write, execute. And it's not doing it. Okay, the reason it's not doing it is because all of these FPC AOIs, they require direct access, meaning if another AOI like this one here is active, then this one here is not able to be executed. So we're going to turn off the execution of this one here, and we're going to just do another read here. We can now get it done. I'm going to do a write now, and put a 1 in there, and we have now written, and we get the done. So turn the thing back off. The values are there. I will do a upload now. And like I said before, we've just modified these values in the controller. Now, these are not permanent, so if I was to cycle power, the values that you have in the volatile memory would be lost. If you want to permanently set them, read the FHPP manual. You'll find out that the PNU 127.2, writing a value of 1, I believe, will permanently set those values in the EEPROM. And that's about it. This one here sets the is designed to set download a variety of parameters or PNUs. If I go to my recipes here, it's an array where 40411, 40421, giving it different values. And if you read the FHPP manual, you'll see that it's writing to the record table. But I'm not going to discuss that today. The idea here is that you write a recipe. Turn this bit on by toggling it. Make sure no other FPC AOIs are active. Put a 1 in here. It goes through them all. I can come into here, do an upload. Keep an eye over here. And it just modified all these parameters right here. And you basically set that up in your array. What else is here? We've done that one, the diagnostics view messages, PNU. We'll set any PNU. And that's about it. I hope this helps. Okay, so the last step here is adding some of your own code. So I have gone through and added some code that act on the function blocks. You know, like whenever you go to a function block, the whole concept behind the function block is that there are tags already associated, and that's what maps to the real world. So if you go up to monitor, you'll see here that the function block, it has tags already, right? So you use these tags without the project or throughout the project to act on what you want the access to physically do. In my case, I've got a mode select. I can just toggle these bits, you know, toggle. So I'm just gonna toggle this bit. It flips it into, of course I need to be online. All right, so let me just explain the code real quick. So this here changes the mode of operation, and it acts on the OPM mode, which is this bit right here, which is these right here, okay? Enable fault reset. So, you know, typically you have e-stops, gates, things like that. The stop and the halt are always on. I never ever turn these off, because if you do, then you just run into problems. The enable bit can be used for everything. When you drop the enable bit, the controller will react accordingly. And these right here, these values right here, whenever you drop the enable bit, the access will decel at that value right there. Okay, so that's important to understand. The fault reset is if there's a fault or a warning, I toggle this bit, I can reset the fault. I have this general safety rung, which is before any move can take place. You have to monitor these bits. So you've got your e-stops, your gates, homing, drives enabled, load voltage, you get the ready. It's not moving. You're not locked out by the FCT software. You have no faults or warnings. The acknowledge is not in the wrong state, and motion complete is on. Under homing, you know, if I get a fault on my Ethernet comms, I unlatch the fact that I've been homed. So that, you know, if I want to rehome it after a communication fault, I can do that. This right here, I simply toggle this bit to execute the homing. I have a little delay here, and it gives me the actual current position. Sequence, I just have a little sequencer here. It runs through a sequence, and the sequence acts on this code right here. So this code right here is for direct mode position. I set up a percentage of velocity, set up a target value, those steps right there will be executed from the sequence, and I wait. I get the command, which means I've sent these values. I get the acknowledge start because this command here in the common control area, when I turn on that in no active, the start task gets turned on. The target scaling goes out as you see here. Back to here. Start task was turned on via this. I wait for the acknowledge. We're now active in its move. Now that we are active, wait for the acknowledge start to go off and motion complete to be turned on. And I latch in a complete. And if you want to close the window around something manually, I can do with this code right here. I always like to be certain that, I create my own window to be certain that I'm at position, because the motion complete is typically in most controllers based upon the theoretical motion complete. And that's just move one, and then that's the same copy paste for each move. When you go to record mode, same concept. I've got a sequencer here, and instead of calling out the velocity and the target, I'm simply setting a record number, and same concept. Acknowledge start after the task request, motion complete, you get a complete. Simple. Go online. Probably wants to sync up. So mode select. Toggle this to direct mode. Again, I just did that. Control T. The drive is enabled. Toggle this off and on. You'll see here that the status of the drive enabled, the ready, motion complete, all change state as well. Turn that back on, everything's good. Homing. There's my current position is 30. Press the home button, it'll move towards home, zero itself out, and the homing sequence is complete. This one here, this resets the whole sequencer if you get screwed up in the middle of it, and simply turn this bit on. I'm just going to lower the speeds here because we're going too fast for my axis here. 15, 11%, 5%. All right, so we're simply moving back and forth. You can see the stepper here. Stepper just continues, it just resets itself, starts over, and follows through here. And keeps going. And when the last step is done, then it resets the cycle, it starts over. Turn the sequence off, drop this enable. We of course have to be in auto mode. And now we're going to go into record mode, record select mode. So toggle this, direct mode's turned off, record select is on. You can see that right here. Our mode is back to 0 now. And toggle this bit here. The moves are extremely short in this particular case. That's why it's racing through this. And that's it. So we've added some code. I've also got some code in the main routine so that if I want to ignore all of my code, I can simply toggle this bit, which, it's right up top here. So I want to act as standalone, because if the code's acting on these variables here or these tags, then you cannot really do something. So by doing this, I'm jumping over the jump subroutines that I have here. So this is off. So I'm jumping over the code now, and the only thing I'm allowing to happen is this right here, along with the status up top here. And at that point, you can go and do your own thing all over again. I can disable the drive, turn it back on, and so on and so forth. And that's it. Function blocks, or AOIs, for the FHPP profile version 2.2. Okay, the last thing I'm going to show you here is a change in firmware. So the previous video is using version 1501 2.2. This is a unique version of firmware, and I understand that Festo will change this in the future, but basically they drop the header information. So when you're using a generic module, the first double integer on the older firmware is the header information. So you need an additional 4 bytes. So this version 2.2 that we've shown you in this, or that I've shown you in this video, drops that header information. So at this point, I'm just going to show you that I'm going to update the firmware and downgrade it. Select an older one. So I'm downloading an older version of firmware. Right now the motor controller is restarting with its new firmware. Controller is starting again. Finished. We're going to go back online. The project has been erased, so we do a download. After a firmware change, when the controller is empty and you do a download, normally you would download and then do a store. The download does the volatile memory, the store does the double EEPROM, but whenever you're doing a first download, you have to take into consideration that safety module there. You're accepting that there is a safety module there and signature on it. The controller will automatically store the program for you on the first download. So as shown, we've downgraded to the 2.1, and now I'm going to go back online to the controller, plug in the Ethernet cable, make sure that's up and running. Okay, so Ethernet cable's plugged in, and you'll notice here, it's not very apparent in this video, but there is a yellow yield sign here. Okay, now that we have done the firmware downgrade to version 4.0.1501 2.1, then we should notice a serious difference, and that's because on anything prior to version 2.2, well, on version 2.2, Festo made some changes to meet some criteria in the ODVA standard. So anything prior to that, meaning 2.1 and earlier, is different firmware and a different data size than version 2.2 and newer. They have said that they will possibly change that in the future to avoid complications like I'm showing, but for the time being, this is the way it is. This is April 2016 we're talking right now. The difference is that in version 2.1 and older, there is a run idle diagnostic header, which amounts to 4 bytes or 1 double integer in the input data structure. So now that I have downloaded and upgraded, so this is the same project in this series, but the firmware is different. This code here is still the same, which was working on version 2.2. And when you go to the generic table here, which is map for 16 input, 16 output, because there's an additional 4 bytes that we have not accommodated for here, the data is in the wrong location. And what I mean by that is if I go to the AOI right now, and I come down to here, if I turn on all these, I'm getting incorrect status over here. All right. So to fix that, I'm going to go offline, and I'm going to open up a different project here. So this particular project here, I have added the extra 4 bytes. Okay, because like I said before, there is 4 bytes as a header information. And in the FML read data, instead of starting at address 0, like in the previous, this is the previous, this is the latest, I'm going to start at byte number 4, and I'm going to push out the FPC data another 4 bytes. So from 8 to 12. And when I download this, then my data will now be working. Again, it's only the input data that is affected, not the output data. So haven't changed anything at all other than get rid of the fault. Fault's cleared. Enable the controller, and now I'm getting the proper status. So basically, the FPC is not here anymore. The FPC is now here. Now the header info is for internal use only. It's got nothing to do with the project. It's just there. You can't change it. And that's when using version 2.1 and older firmware in the controller.